how can the flows be classified? There are different types of flows. So these types of flows are, one is steady flow and other is unsteady flow. And other is uniform flow and non-uniform flow. Then laminar flow and turbulent flow. Then we have compressible and incompressible flows, rotational and irrotational flows. Then we have one-dimensional, two-dimensional and three-dimensional flows. We will see each one of them in detail. So what is a steady flow? In this figure you can see that in a steady flow, see what happens to the flow after some time. You can see the flow remains same. And in the case of an unsteady flow, after some time you can see that the velocity is changing with respect to time. So steady flow is a type of flow in which the properties of the flow change with respect to time. That means properties like velocity, pressure, density. So in mathematical terms, we can see that dou v by dou t will be 0. That is change of velocity with respect to time. Change of pressure with respect to time is equal to 0. Change of density with respect to time will be 0. This is called a steady and unsteady flow. Now let us see what is a uniform and a non-uniform flow. In a uniform flow means is a flow in which the velocity is same throughout the space. That means velocity will not vary with respect to space. So S means space, that means you can see dou v by dou x will be 0, dou v by dou y will be 0, dou v by dou z will be 0. You can see in this figure that is a non-uniform flow. This velocity is in the y direction, velocity is changing. As you go down, you can see the velocity is different from the top layer. So that is a non-uniform flow. So uniform flow means a flow in which the velocity will not change with respect to space. That is either in x direction or in y direction. There will be, or in z direction. There will be no change in velocity. Now let us see what is turbulent and non-turbulent flow. A turbulent flow is a flow in which the fluids are flowing in layers, layer by layer. You can see that there is one layer here flowing with the velocity here. There is another layer, there is another layer, like that. It is flowing layer by layer. Layer by layer. And in a turbulent flow, you can see that this fluid is flowing in a zigzag manner. Each layer is crossing each other. So that is called a turbulent flow. See, this creates a lot of eddies. These are the eddies which causes a loss in pressure and velocity. There is a laminar and turbulent flow. You can observe that in a pipe. Initially, the initial part of the flow through the pipe will be laminar, and as you go down, as water goes down from the pipe, it will become turbulent because the velocity increases and laminar flow will be changed to a turbulent flow. So what is the difference between a compressible and incompressible flow? You can see here the first figure. In a compressible fluid, when a pressure is applied, see its volume is reduced. And in the second case, in an incompressible fluid, even if you apply the pressure, there will not be any change in the volume. So that simply means density will be constant. There is no change in density. For example, water. So its density will not change very much with respect to pressure. But the case of air or any other gas, density will change with respect to pressure. it can get compressed. So that's the difference between compressible and incompressible flows. Then we have one-dimensional, two-dimensional, and three-dimensional flows. So you can see here in the one-dimensional flow, the flow will be in the only in one direction. That here it is in the x direction, and here you can see it will be in the second case there is a two-dimensional flow. See, the flow is in a slanting way. That means it flows both in x direction and y direction. You can resolve that here. There is x component and y component. Similarly, in three-dimensional flow, see, the flow will be in both x, y, and z direction. It has got components in each direction. Now we have the rotational and irrotational flow. Rotational flows is that type of flow in which the fluid particles, while flowing along a streamlines, also rotate about their own axis. And incompressible flow, the fluid particles will not rotate about their own axis. This is the main difference between rotational and irrotational flows.